This is section 4.4, part 3 of 4. We're doing word problems using linear systems. In this first problem, we're going to need, actually on both of the next two problems, we're going to need a formula we haven't had before. And these are what we call distance problems. The formula we need is D equals RT, which is distance equals rate times time. So if we want to know how far somebody traveled, we need to know how fast they were going and how long they traveled. Simple as that. Okay, now distance problems, people make fun of them. They make them sound like they're the hardest kind of problem ever, when really they're among the easiest word problems we do. They pretty much all work the same way. And for the majority of them, you draw a picture and it will help you figure out what's going on. So let's look at this problem. In 2002, Atlanta's Hartsfield Airport was the nation's busiest. Suppose two planes leave the airport at the same time, one traveling east and the other traveling west. If the planes are 2,100 miles apart after 2 hours, and one plane travels 50 miles per hour faster than the other, find the speed of each plane. Okay? First of all, this first sentence is context. It gives us nothing as far as the math goes. Okay? First read through, let's see if we can figure out what we're being asked to do. We have two planes going in opposite directions. We know they are a certain distance apart after 2 hours. We know one of them is faster than the other, and we're supposed to find how fast each one goes. Remember, on the first read through, just understand what you're being asked to do. You don't have to know how to do it. And what I'm going to do is I'm going to draw a picture and see if I can figure out what's going on. Okay, so if this is my airport, one of them is going east and the other one is going west. We're told one is faster than the other. It doesn't matter which one, and we're not told which one, so we can pick one of them to be the faster one. We'll get there in a second. We know that after a certain amount of time, the distance between the two is 2,100 miles. And they have traveled for 2 hours. Okay, and they left at the same time. That's an important thing to recognize as well. Now, what we don't know is how far this one traveled. We don't know how far this one traveled, and we don't know the rate of each one. So let's say this one is going X miles per hour, and this one is going Y miles per hour. Okay. Let's also say that this one is the faster one. It doesn't matter which is which. Okay. Now, would you agree that if I could find a way of talking about this distance, and I could find a way of talking about this distance, I should be able to add these two distances together and get this? Physically, you can see that that's true. Okay, well, let's see if we can do that. Distance equals rate times time. We're looking for the distance. Just this plane. We don't really know how fast it's going, but we're calling it X. So that's our rate. How long did it travel? 2 hours. So this distance is 2 times X. We do the same thing here. We don't really know how fast it's going, but it's been going for 2 hours. So its distance would be 2y, however fast that's going. Okay, so we've really just built our first equation. 2x plus 2y has to equal 2,100 miles. Okay, what have we not used? We have not used that one's faster than the other. So the difference between the two has to be 50, right? We said this one was the fastest just because. So you take the fast one, you subtract off the slow one, and you should get a difference of 50 miles per hour. This is the system we need to solve. Okay? So we want to match up our coefficients but have opposite signs. This one's probably going to be the easiest because it already has opposite signs, and that's a 1 there, so it's easy to change. I need a -2 here, so I'm going to multiply this entire equation by a 2. recopy my first one. Multiply through the second one. Now add these together. The two y's cancel out. I get 4x is equal to 2200. Divide both sides by 4. And we get x is equal to 550. Now, we're not really, doesn't matter, I chose x and y there, it doesn't matter east or west, we're just told two planes. So the first plane is going 550 miles per hour. We're asked to find both, so I take this and I plug it into one of these two equations. I'm choosing this one. That gives me 550, let's get this up a little bit, minus y is equal to 50. Subtract this over to here. Now I know my answer can't be negative because planes don't travel negative miles per hour. As soon as I get negatives in here, I start to be really careful. I don't want to lose one. I don't want to mess up my signs. This cancels and I have negative y is equal to, this is negative 500. And remember, whenever we solve for a negative y instead of a positive y, we just change the signs on both sides. So the second plane is going 500 miles per hour. Seems reasonable.